Welcome back. In this video, I'm going to talk about two things. First, I'd like to show you the motion instruction application with the welding program. As you can see, I have a welding program on the teach pendant. So, like I can run the program now. Like you can see that demonstrate the movement with the welding. So I can demonstrate that motion. All right, so there's some lagging still. Maybe zoom in a little bit. Let's see the motion. All right, it's just like do a welding on a part. All right, so this is the first thing I want to demonstrate with this video. The other thing I want to demonstrate is that if you notice, this is a short program, right? But we have two instructions at the beginning to set up the user frame number. Of course, we have to set up the two frame, right? Because it's a welding gun. It's not the pointer anymore. What I want to demonstrate on the second part is that uh, I'm going to move this blue box to somewhere else. Then the program right now running on the part perfectly, it won't be good anymore because the box changed, the location changed. And remember, I mentioned one of the application with the user frame is to allow you to make some adjustment. Once you adjust the tool frame according to your new location, the program you recorded on the old location is you can still run on the new location. So that is what I'm trying to prove. All right. So let's look at the program details. All right. Before we begin, speaking of these two new lines on here, so in order to make the program unified, and later on I'm gonna ask you to do this as a lab by yourself, right? So I need to check your dimensions. So in order to unify that result, we have to make sure the user frame and tool frame it's exactly the same thing for everybody. So as a starting point, all right? So um, that means we have to use the direct entry to make sure everything, all the frame setup is same. All right. So if you still remember, we're going to menu 6 setup. So if you have the last time result, you should see here, you're in the screen on the user frame number one. Let me get my pencil user frame down here and user frame number one. So if it's not direct entry, you need to press F2 to get a direct entry. Then you need to enter those value, right? Because you may use uh, I ask you to use the 3 point, you may get a different result, right? But in order to move on, I need you to have this unified result on the user frame, right? So I'll clear up so you can look at it. So X 500 and Y 1000, Z 330. I explained that, right? How do we get these three numbers? And also the yaw and pitch are 0 and the R is 90 degree. All right, so you need to make sure you set up user frame according to this. Right. The other thing is that we have to check the two frame. So if you remember how to get it down there, you need to press previous, and then you're looking at all the 9 different user frame. If you press F3, you can change it to user frame screen. Once you get into user frame, I want you to go to number 6. So with number 6, this is the number I want you to enter if you don't have the result showing on here, right? Again, you need to choose the user two frame, sorry, number 6, and use direct entry method. Make sure your X is minus 91, Y is 0, Z is 403, and the yaw is minus 36, and the pitch is 0, and the R roll is the 90. right? So that is what you need to set up before you can design the program, right? Otherwise, it'll be really uh, hard for us to have the desired result, right? And this is the program you need to enter. It's very short. I just want to use that as a demonstration, all right? So let me put it into the step mode so we can have a look. So the first two lines just set up the frames, right? You have to run it to get the frames you want, right? And once you get into the position, let me show you on here. So this is the starting point, right? So it's far away from the fixture. We're trying to weld the part on the box, start from this corner. So shift forward again, that will be that position on here. So let me zoom in to show you details. All right, so first I need to let you know that I'm using the Handling Pro software, right? So this is not the real welding simulation. Fanuc has the package to let you to simulate the welding process, and also you're supposed to have different instructions. It's not like this, all right? So you can see here, we are still using the handling pro instruction, motion instruction, but with the welding package, you're supposed to be able to control the weld on, weld off to turn on the welder, right? And over here, I don't have that, but I can demonstrate the motion, right? And the other thing I wanted to mention to you is that the welding, robot welding is a very complex process. Different company, they have different requirement according to what type of welding you're gonna use. Right? Over here, I'm showing the mag welding, spot welding, right? And you can see this is the welding torch, and you have the wire coming out, and you can see inside here. I'm sorry I couldn't get the color background. They should have different colors, right? So you can have a like very real feeling on the tooling, right? But you can see here inside there's a that's the welding tip, right? The welding wire coming out from there, right? So that is the welding gun you're going to work with, right? So you suppose to position your welding gun. I'm just talking about the basic uh, guidelines. All right, there are lots details. Maybe if you working in the uh, with the robot welding application. So first thing is that your wire is supposed to be going to the welding surface roughly in 45-degree. Right, so 45-degree give you the best angle you can get to the weld. So that's first thing, and then the uh, if I rotate on here, you can see the welding, zoom out a little bit. You can see the welding gun. You need to position your welding gun in that 45-degree on the weld. And also, if I rotate on this way, there's supposed to be some sort of angle. So you can see here, I can draw the line here. If you draw the line here, right, sorry, that's not straight. So if you have a line here, you welding on here supposed to have maybe a check on the internet. Lots welding expert mentioned that it's supposed to be 12 to 15 angle on here, right? So you need flip the welding gun this way a little bit, then you push towards your welding process, right? So in this way, you will have a better welding result. You don't have a lot of they call spatter, right? So that's a big thing with the quality control. All right. Again, um, and also speed, right? Over here, I just choose random speed, and you understand that definitely gonna make a huge difference on the result of welding, right? So I'm just talking about the basic setup on the welding, right? So if you go into the industry to work with this type of application, for sure they will have a detailed requirement. They even have the welding tag to check the result, right, with the robot result welding. All right, over here again, I just want you to know that sort of requirement exist, right? So it doesn't just happen randomly. So that's pretty good. At least for me, is I did my best. That's the good starting point with your well, right? Then you can see here, it's a linear, right? You're going to there very accurately with the fine termination. Then the number six, line number six will be on this corner, right? So, oh yeah, I forgot to mention uh, the distance between your TCP. So that's why we need to set up the two frame, right? So you can see here, I have a measurement. So from your TCP to that corner, you're supposed to have in your lab, if you want to get a sign off, you're supposed to have the distance within the positive uh, with the 4 millimeter distance. You don't want to go too far, right? I need you to get into very close. So right now it shows 3.3 millimeter, right? You need to get in within 4 millimeter to get it sign off. So this is the starting point. And then on the ending point, that'll be the other corner on the fixture, right? So if I shift forward with the step mode, you will see it just weld to the end on that corner. So you finish the welding, then the line number six, number seven will be the retreat, right? You leave that job position, you just go away, right? So you understand that we did that with the previous labs, right? So this is the welding program I want to demonstrate to you. So I'm gonna take off the stack mode and run that program again. All right, so you can see the whole process. That's a demonstration with the welding process, right? So this is the, remember that the first thing I want to demonstrate, give you some sort of feeling with the welding process with the welding gun. So now I'm going to demonstrate the second thing with this video. So because we have a user frame associated with this job, right? So if we want to make some changes on the box, for example, this blue box, I want to make some changes. When you double click, you will see here, uh, I want to move this box location to the other side. So like I want to move this whole thing to here, like around here. All right, so to do that, uh, I just need to change the coordinate on y. All right, so negative on there. So if I apply, so negative 150, that will move the whole box on here. But notice it's just the shift to there. But I want to have same thing uh, rotate on there. So that welding you can see here, it used to be on the outside, but right now become inside. So that's why I need to change this R, which is rotation around Z, to 180 degree. So I flip the box. So I'm gonna change this 180, flip the box in this direction. Uh, let's see if I can do that. All right, so apply. Yes, so you can see I flip the box to the other direction, right? So you can see this totally change your program, right? So I close this and clear out that. So if I run the old program again, shift forward, you can see robot just the robot doesn't know the box move, right? So it's just running the old program again and again, right? So it's a line welding, right? But the whole thing is already moved to there, all right? So here's the magic happen, all right? Because we have the user frame associated with this program, so we don't have to retouch up those positions. We just need to change the user frame. Remember the user frame we set up on the corner number one, right? So if you want, you can redo that again, right? Change that the tooling to pointer and use that corner number one to do that 3-point method again. So then you will have a new frame set up. But because I did that with some mathematical relation, so I can use the direct entry to change the user frame right away. All right, so before uh, we have certain numbers on the user frame. I can just open it up, set up number 6, then this is 2 frame, right? So again, previous, then I can go to other frame. I'm going to use the user frame number 3, and that's the user frame number 1 I'm using. So I'm going to details, and right now I'm in the direct entry. If you're not, you can choose from here, right? So direct entry, so that's the old location of the user frame. All right. So, but if you look at here, if you remember when I talk about the frame setup, user frame is just the offset from the world coordinate, right? World frame. Remember here, you can see the red triad here. This is the 000, right? So that's the reference starting point. And it used to be on this side, the box on here on this side, and now we move to here. Remember the corner number 1 is the our original point, right? So if you look at this new location, in relevant with the 000 on the robot, on the X, right? This is on the minus 500, right? Half of the square tile on the floor. So that's why the X should change to minus 500 instead of positive 500. And same thing for Y, right? This is 0, and that move to this way to the corner number 1, right? So that will be minus 1000 on Y. So we need to change this to minus 1000. The Z doesn't change. The height is the same, right? We will keep this 330 on here. And also remember that I flip the box with 180 degrees. So in order to have the same uh, orientation, right? So because of that, we have to flip this R also 180 degree. So that means we can get to negative 90 degree. So that be the totally 100, 180 degree, or maybe you use 270, that'll be the same, right? So uh, now I'm going to start to change those numbers, right? So over here, I'm highlighting the R, right? Was 90 degree. I need to type in minus. So let me try here. Yeah, so minus 90. So that is what I want. And then I need to go up. Z doesn't change. And this changes to minus 1000, right? So you understand the relation with those numbers. So X, we need to change it to minus 500 because that corner, right? Corner number 1, uh, explain that. All right, so we change this frame number to exactly what I want, and then let's run that program again. So that's what I'm saying. All right, magic happened. Right? Before a robot is running the old program. Now, if I shift forward, run the program again, then the robot controller will get the new data we just entered on the user frame number 1. Right, 2 frame doesn't change, then we should get the robot weld from this corner to that corner again, right? That's exactly the same as before. So you can see robot start there and then well finish, right? Is it that exciting, right? So I think that's a very cool on here. So if I zoom in, I can let you to look at the detail on the program. So because we did that mathematically, and that guaranteed to be exactly same as before. Remember on the other side of the box, right? So if I turn on the step mode, shift forward, and you will see robot is there, and the starting point, remember there's 3.3 millimeter, and let's see if that keep on there. Yes, I can see that starting point. Yeah, 3.3. That's exactly same as before. Starting point, same angle, everything is the same, right? So then starting from that corner, if I shift forward, and then that's gonna finish the well on this corner, and then go back, Right. So if you understand this, you can even change the box back on the other side and make some adjustment on the user frame. It will return to the original state. Right. But for demonstration purpose, I just want you to look at that. By using the user frame, uh, we can save a lot of, potentially save a lot of work. Right. So we just need to make the adjustment on the user frame. So this is one of the typical application with user frame. Of course, it has lots other applications, right? But it start from this one. You can start to understand. All right. Okay. So I think I'm done with this video. All right. See you.